So let us learn about functions today. Function, they make up a big part in algebra, and I would say that almost all of the calculus or the advanced mathematics, when you study that, it will rely really heavily on the understanding of functions. Okay, so when I think of a function, I think of the three key and main elements. It is called the input, the output. Let's say input is I, the output is O, and then there is something that separates the input from the output, and this is called a transformation of some sort. A transformation that creates, of course, a linkage between input and output, but it converts every single input into some sort of one output. Okay, now I used a keyword here. It is called one output. What it means is that every single input we send through this transformation should have only one output. All right, one input should not result into multiple outputs, and that is the key thing that defines or that says that what is unique about functions. Okay, so for example, let's say I have a transformation, and this transformation is about dividing any number by 2. Dividing by 2 is my transformation. So when you have such kind of transformation, and let's say you send an input of 4 to it, you get 2, right? When you send an input of 10 to it, you get 5, because 10 divided by 2 is 5, 4 divided by 2 is 2. So you see that there is a unique linkage of each input to its respective output, because each one of those is going through this division operation, right? So this is a very brief and very simple idea about what is a function, right? I will also tell you this, that whenever you think about a function, think about this little flow diagram. The flow diagram says that there is some function, and what that function is doing is, if this function takes an input and one input results into multiple outputs, okay, as shown by these blue arrows, one input, the red arrow, results into multiple outputs, then this is a classic example of it is not a function. All right, always remember about this little flow diagram we have. But in addition to the flow diagram, we need some written statements, or we need some rules of how to distinguish a function in a data set or in a graphical way, right? So when I talk about a data set, there are 4 different rules that define the criteria of a function. Okay, and these are the 4 questions actually: 1, 2, 3, and 4. You always answer these questions in this sequential manner. First, for any given data set, you always check, is there an input? And the answer has to be yes. If it is no, you stop right here. Is there an output? The answer also has to be yes. Does every input have an output assigned to it? It also requires an answer of yes. And finally, does the output repeat if the input repeats? And the answer of this has to be yes. The moment you see these 4 yeses in these questions, you will say that that respective tabular data or that respective process is a function. Okay, so let us go through some examples to best understand these questions. All right, so what I have with me here is 5 different data sets. Each one of them represents some input in the top row, and then there is an output in the bottom row. Okay, so we have to define whether these data sets, do they represent function or not. Okay, we don't care about what function, all we need to find is there a function or not. All right, so the first one, the data set A, there is an input, the top row, but there is no output underneath, right? Every single one of them is a blank, right? So what does it say about this data set? I would say this is not a function, because there is an input but there is no output, hence it is not a function. As simple as that, right? The next one is, there is an input and there is an output as well, right? But you notice that there are 2 specific inputs. -2, it has an output of 3, and then there is 2, it also has an output of 3. I would say this is a function, because the rule is every input should have an output, right? It doesn't say that 2 different inputs cannot have the same output, right? 2 different inputs indeed can have the same output, and that's exactly what this case is. So we will say that this is a function. In the example C, we see that there is only one input, right? But there are multiple outputs to that one input. So I would say this is not a function, because a function doesn't define a rule that one input can have multiple outputs. Multiple inputs can have one single output, that is okay, but one input cannot have multiple outputs. Okay, so finally we have the last two. The D, I state here that there is an input and the output is all same. All 10 different values of input will give you only one output. I would say this is a function. It is exactly opposite to this scenario, right? And we said that multiple inputs, they can give you one output and it will be still called a function. And finally, the last one I have, the table E. What we see here is that the input and the output is exactly the same. So what do you think what is happening here? Okay, so what is happening is I take an input, I multiply that with 1 and it gives me the output. So what will you say then? Is this a function or not? That is a question mark for you, right? Think about it. I would say it is a function because multiplication with 1 is also an operation, right? And that is exactly what is happening here. So this is a classical example of how do you distinguish whether one given set of data, the input and output, whether do they represent a function or not. Okay, with that, let us pause here, and in our next tutorial, we'll study a little bit more about how to interpret functions if you have been given the graphical form of data. Okay.